I get asked the question all the time, why not just teach the standard algorithm? Why not just get to the answer really, really quickly? Why can't we just follow what we have done in the past and be able to teach our kids the procedure instead of having to do all of this extra work? Well, actually what we've found is that that tends to be very inefficient if it's only taught that way and not taught with the understanding of why it works. So for example, when kids do 73 times 10, they actually do the entire algorithm all the way out. 3 times 0 is 0, 7 times 0 is 0. We put the placeholder in. 3 times 1 is 3, and 7 times 1 is 7. We add it together and it comes out to be 730. When in reality, if they understood why it works, they would have been able to say to themselves, 73 times 10 is 730, because they understand that this is a 10, and so this is only, the digits are moving out one place, and so therefore it becomes 730. Okay? So that is the biggest reason why the standard algorithm becomes inefficient if that's the only thing you know how to do. So procedure actually becomes an issue. We want kids to be able to develop and nurture their flexible thinking skills, and we want kids to be able to develop mental math, because mental math trumps memorization all the time, and we want kids to be able to think instead of just do. And that's the biggest issue today, is that we want to make sure that kids develop stronger mental math capabilities by not having to just do the standard algorithm, but being able to utilize the standard algorithm with the rest of the process of understanding why it works. So why are we teaching math so differently today? Well, let's first look at the standard algorithm. If we took the problem of 37 times 23, now I'm going to first multiply these first few digits. So 7 times 3 is 21. I'm going to put the 1 there, and I'm going to regroup the 2, but I don't understand why. I just know that I'm supposed to put a 2 there. And then I do 3 times 3 is 9 plus 2, because I can't forget to add this 2 in, makes 11. But I don't understand exactly why I'm doing that. I just know that I'm supposed to do it. And now I come down to the second line of multiplication, and so I put a placeholder 0 there, just because I know I've been taught to do that. And now I can start multiplying. So now 7 times 2 is 14. So I put the 4 down and I regroup the 1, and I don't need this 2 anymore, but I don't understand exactly why, but now there's a 1 there. And then I do 3 times 2 is 6, plus 1 makes 7. So I put the 7 down, and now I have to add it. And when I add the whole thing together, I get 851. Now, this is the actual standard algorithm, and this is a very easy procedure to do, but it's not completely understood as to why I needed to do all of this in order to accomplish it. Now let's look at the next step, which is actually called a partial product. And it's where we actually take in our place value skills and try to understand why the problem works the way it does. So if I take 37 times 23 again, and now I'm actually going to do the partial product. So I'm going to do 7 times 3 is 21. And then I'm going to do 3 times 3. But this time, I'm not looking at it as 3. I'm recognizing that this is in the tens place, and so it's 3 tens, and so it actually represents 30. So 30 times 3 is 90. And so if you see, 90 and 21 makes 111. And that's where the 111 comes from, is from that 90 and the 21. Now if I do the next one, which is 7 times 2 is 14, but this is actually 7 times 20, which makes 140. And then this is 30 times 20, which makes 600. And if you see that if I add those two together, I get 740, which is the exact same number over here. And then if I add all of those up again, I get 851. But this time, through partial product, I can see the place value of each of those numbers, which we consider distributive property. And so in reality, I'm not just looking at this as 3, I'm recognizing this as 30. And I'm not looking at this as just 2, but I'm recognizing this as 20. And so my place value starts coming in, and the concept starts coming in, so that way I can understand why the standard algorithm works because of my place value ability. But now, when we look at it in a third way, which is the area model, we can then take it the next step further and break it up into its individual pieces like this, and recognize that 37 is actually 30 plus 7, and 23 is actually 20 plus 3. And so now I'm going to break up my numbers immediately and start multiplying them in their specific place values. So now I'm going to do 20 times 30, and I'm going to get 600, and that's why this is the biggest box, because actually I'm also solving for area at the same time. And then I do 20 times 7, and you get 140. And then you do 3 times 30, and you get 90. And you get 3 times 7, and you get 21. And now I'm going to add all of those up, and this is going to come out to be 161, and this is going to come out to be 690. And if I add these two together, I'm going to get 851 again. So now you see that the area model and the partial product developed the concept of what the standard algorithm has been doing over all this time, but now I can understand why this works, so that way I can do further problem solving later on and become a better problem solver. So now we're going to focus in on how to do the area model part of the process. So we're going to stick with 37 times 23. Now the first thing I'm going to do is I'm going to draw my box. And in drawing my box, now I'm on the top side. I'm going to represent the first number, 37. But when I represent 37, I need to break it up by using distributive property of its place value. So I have actually 3 tens here, so a 30, and I have a 7. So if I was to write this out, it would be 30 plus 7. Now, the next one is to go vertically on the y-axis. And so here I'm going to do 23, and I'm going to do the exact same thing, 20 plus 3. Now, in representing this within the boxes, I need to realize what the largest space is going to be. 30 is much larger than 7. So as I draw my line down, breaking up 30 and 7, I need to make sure it represents based on size. It correlates to their size. So 30 is much larger than 7, so therefore I'm going to put a vertical line down representing the space of 30 is much larger than the space of 7. And the same thing with 20 and 3. When I go horizontal here, the space of 20 is going to be much larger than the space of 3. And so now you can see that this box right here is actually going to be the largest area, because in reality what you're looking at here is the area of each of these boxes. We are going to be multiplying the length and the width of each of these different boxes and then adding it all together. That's why it's called area model. Okay? You're actually finding area. So here, the first set is this first set of boxes is I'm going to do the vertical times the horizontal here. And so I'm going to do 20 times 30 inside this box. And so I write 600. And then I have to multiply this 20 times the 7 over here. And so 20 times 7 is going to be 140. And now I come down to the 3, and I multiply the 3 times the 30, and I get 90. And then I multiply the 3 times the 7, and I get 21. Because it correlates in the boxes. It's almost like you're doing grids as well. All right? And so now taking all of this, now you have to add it all up. So we can either add going all the way down, or we can add going across. Either way will work. So if I added going across, this would be 740, and this would be 111. And I could add those two together. Or I could add going down, so 140 and 21 makes 161, and 690 makes 690. And both of these will come out to be 851, 851. And that's how you do area model with the standard algorithm. So now looking at area model, we can see why this can be more efficient than the standard algorithm that we've seen before. And it seems like it might be less efficient due to the fact that it seems like a lot more. But in reality, what the kids are seeing are the numbers in a new light. And so you're seeing 37 and 23 in different ways. Instead of just 37, it's now a 30 and a 7. The kids are seeing the numbers in their place values. And so it's going to improve their flexible thinking. They're going to be thinking more outside the box. And they're going to be considering the fact that these numbers are capable of being mental math skills. And so they can see that it's 20 and 30, and 2 times 3 is 6, and the 2 zeros represent the hundreds place, so now it's 600. They can actually utilize these skills in a more mental math capability. And so it improves all of the areas that we're looking for, so that way they can be more flexible and more outside the box and more problem solvers later on in life.